Before watching the video, don't forget to subscribe to our channel by clicking the subscribe button below and clicking the bell icon to be notified whenever we publish a new video.
The function of a closed-loop system is to monitor and automatically maintain a variable at a desired set point in a manufacturing process. Using an example of a heat exchanger, the operation of a closed-loop system is compared with a block diagram. The heat exchanger supplies heated water to a food processing operation. Cold water enters the bottom of the vessel where the water temperature rises as it passes through steam-heated coils before flowing out of the pump at the top. Each block represents a function of the operation. Lines connecting the blocks indicate input and output signals of each function, with directional arrows indicating the process flow. The controlled variable is the actual variable maintained in the process. In this example, the controlled variable is the temperature of the water leaving the tank. Measured variable monitors the status of the controlled variable. Water temperature is the measured variable in the process. The measurement device senses the measured variable and produces an output signal that represents the status of the controlled variable. The thermal sensor that measures the water temperature in the heat exchanger is the measurement device. The sensor provides an electrical signal to the controller and is defined as the feedback signal in the block diagram. Set point is the predetermined value of the desired condition of the control variable. In the heat exchanger, the set point is the programmed value of the water temperature leaving the tank. Error detector compares the set point to the feedback signal and produces an output proportional to the difference between them. Error signal is the output of the error detector. If the feedback signal and set point are equal, the error signal is 0. The controller is the brain of the system. It receives an error signal as it inputs and provides an output signal to the final control element or actuator in this example. A signal from the controller causes the controlled variable to match the set point using the actuator of the system. The flow valve represents the actuator where steam flow is controlled. The amount of energy or steam in this example, altered by the actuator, is the manipulated variable. Manufacturing process is the operation of the heat exchanger to control the physical variable. Disturbance is defined as a change in the manufacturing process resulting in a change in the control variable. Disturbances occur when the water temperature suddenly changes or stops flowing. Closed-loop control and the associated terminology are common within manufacturing systems where precise control is required.
Thanks for watching. If you like the video, give it a thumbs up and share it with your friends. For more tutorial and tips, subscribe the channel.